Hello everybody, welcome back to my channel. I am Zach Peterson. Of course, you know me from the Altium Academy videos, but I decided to bring all of your viewer questions over here to my personal channel to answer your viewer questions. We're gonna go over some of the viewer questions from the Altium Academy videos today. Let's go ahead and get started. Let's jump right in and take a look at our first viewer question. This question comes from our setting up a Crosstalk simulation video on Altium Academy. This question asks, hi, how did you create that microprocessor and DDR first? It's confusing. I think this question is referring to how the footprints were created for the microprocessor and the DDR chip that were used in the Crosstalk simulation. Now, in this simulation, it is a post-layout simulation, meaning that you have to have traces routed in the board, and then it's going to run the simulation based on your actual layout. And so in order to lay out anything in the board, you of course need to have footprints for the components. So I think, don't quote me, but I think that those particular components were pulled from the manufacturer part search panel in Altium Designer. There are third-party services that give you free access to PCB footprints, and if you don't find something in your CAD tool, whether it's Altium or some other CAD tool, you can of course go to one of those third-party services to get footprints. One great one is Ultra Librarian, another great one is of course Snap EDA, and there are some others that are out there like Semaxis. This next question comes from the second video that I ever did for Altium Academy. This video is all about defining ground in mixed signal PCB design. Judson Antu asks, what if your boards are small enough that the end of the Gaussian distribution is coming over the analog part of your board? How do you lay out then? So this question is asking about the distribution of current that makes up the return current in a ground plane. So this video is all about grounding in mixed signal PCB design, and frankly, the easiest and most effective strategy, both from a noise control and EMI control, that covers, I would say, 75 or 80% of all mixed signal boards that you will design, is to use a single ground plane. And when you have a single ground plane and you have traces running over that ground plane, the return current that you induce in that ground plane tends to be a Gaussian distribution, or approximately a Gaussian distribution in the ground plane. Now, of course, that is also frequency dependent, and as you get to high enough frequency, into the kilohertz range or higher, that ground current tends to lie mostly underneath that trace. Now, the question is asking, what happens if the board is small enough that the Gaussian distribution, or the region where the return current exists, is now overlapping into the analog section of your board? Well, a couple of things. It's a matter of frequency. So at lower frequency, it is possible for all these return currents to overlap, and then you can get noise bleeding through to different parts of the board. The other issue here is that if you're dealing with a ground plane and you have a large number of high speed signals or high frequency signals, you have to get those signals so close together that they were going to create crosstalk anyways. So the issue is not whether or not it's a small board. The issue is, what is the density of signals that you have in the board? As you bring all those signals together, you're going to get crosstalk between them. Once again, we're in a Zach Peterson video, and somebody is asking about, you guessed it, ferrites. This video is a 1-minute design review, and we have a question about ferrites on this video. You often advise people to remove ferrites. Do you have a video on why they are bad or how to use them correctly? Also, is there a practical difference between ferrites and small inductors? Man, I love this question because we answered literally every single point in that question in another video on Altium Academy. So on one of those videos on Altium Academy, we looked at Steve Sandler's thoughts on ferrites because, of course, in one of the 1-minute design reviews, I had quoted Steve Sandler, who is famous for saying, the best time to use a ferrite is never. Well, in that video on Altium Academy, we looked at what are some of the reasons for not using ferrites, specifically in applications with the digital PDN, and we looked at how they are different from inductors and what their effect is on things like PDN impedance, output impedance, and noise. Check out the link in the description for that video and make sure to go watch that. It will answer all your questions about ferrites. Our next question comes on the to pour or not to pour video. This is all about copper pour in PCB design. And Moonman writes, meanwhile, me having no clue what I am doing, just filling up all the empty space on the top layer with pores and vias because it looks cool. Well, you're right, Moonman. It does look pretty cool. And I think that's one of the big reasons that people do it. It makes their design look complete. It also is something that you may see another designer do in a totally different context and totally different application. And just because one person does it in their board doesn't mean that you should always do it in one of your boards. I think it's important to understand the context behind some of those design guidelines. Copper pour is no different from any other design guideline that we've discussed here on this channel or on Altium Academy. This next question comes from the Setting Up Design Rules for Via in Pad guide for Altium Designer. This is a great question. It's actually not really a question, it is a video request. How do you make multiple power rails start up in the desired order? Well, Audio Simon, the easiest way to do that is with a power sequencer chip, and we did a video on Altium Academy about that exact topic. Check out the link in the description to that video. I think I also left it in a reply to your question. Make sure to check that out. It'll answer all your questions. Next question comes from the fastest ways to run a BOM review video. Can the tools handle a BOM that already contains alternatives? The answer is yes, and the tool will display candidate alternatives for you if you haven't selected them already. I think that's a very cool thing about the BOM portal, and frankly, it's one of the things that I have always wanted and liked most about distributor websites and BOM tools in general. These tools that can give you an alternative, I think they're really great because whenever that desired part goes out of stock, the process for finding an alternative can take a lot of time, and if you have something that gives you a suggested alternative, it is a huge time saver. Normally, in the past, I would have gone over to like DigiKey or Mouser and tried to see if they suggest an alternative, but of course, now you can see it directly inside the BOM portal in Altium 365. This next question comes from our Stitching Via Deep Dive video, and this video was all about stitching vias used in applications where you are connecting grounds on multiple layers. This question says, I have a question. Let's assume all of my ground planes are connected by stitching vias, and let's assume my top plane has all the RF signals and no ground plane. Now, I'm going to jump in here and just say that this is a little bit of an oxymoronic question simply because you're saying that you have multiple ground planes, but then you have RF signals on the top with no ground plane. So it's a little bit of a contradiction there, but let's go ahead and keep reading because the reference is the second layer. Oh, so you do have a ground plane, it's just on layer 2. When I connect the ground of an IC from the top layer, should I use buried vias from the top layer to layer 2 or another set of stitching vias that crosses the whole stack up, or does it make no difference? I know electrically it's the same, but maybe one is preferable from a noise perspective. If the only thing you're doing is trying to provide shielding effectiveness for the RF signals on the top layer and you're using stitching vias to do it, the answer is no, it does not make a difference. And frankly, it would be preferable to use buried vias if you are intentionally building an HDI buildup on that top layer. Now, normally in a lot of RF designs, you're actually not doing that. You are using a standard through-hole construction, and so you would then, of course, want to use through-holes. But there are applications where you do have HDI on one or more layers on the outside of the board, and you could contain RF signals on those layers, and so it's perfectly appropriate to use buried vias or blind vias as the shielding element in those interconnects. There are examples with reference designs where an HDI buildup film is used on the outer layer to contain all of the RF interconnects, and guess what they use to shield those interconnects? That's right, they're using blind vias. So it's perfectly appropriate if you do it. Now, essentially what you're doing is you're confining the electromagnetic field in that top layer, and if you have a ground on layer 2, then it's going to totally confine it, and frankly, the presence of through holes will not make a difference at all. The reason through holes could be bad is because they could interfere with routing on your other layers. So in that case, it makes perfect sense to remove the through-hole vias and just use blind vias instead. This next question comes from our length tuning and differential pairs video. This is an older video, but I think this is a really fundamental topic for dealing with differential signals. This question asks, is it necessary for an analog circuit with differential signals as well? Basically, the question is asking, do we need to use length tuning on differential lines that are part of an analog circuit? Well, analog differential signals are not as common, but of course they are used. And the answer is yes, you should ensure that the lines in a differential interface carrying an analog signal are phase matched. And that usually does mean they are also length matched. Now that's very important because when we're dealing with analog differential signals, we care about the phase because we want to line up the wave fronts in the positive and negative polarity portions of that interface. We want to make sure that the wave fronts coincide, and to do that, we need to reduce the phase difference between the positive and negative polarity as close to zero as possible. This is a bit different from what we do with a differential digital signal, because with a differential digital signal, we just make sure that the positive and negative polarity ends of the interface are crossing at the same instant in time, and there is actually quite a bit of timing margin that's allowable for that crossing. Whereas with an analog signal, you would want to make sure that they align close to zero phase difference as possible. This next question comes from our reverse polarity protection video. This question asks, I am confused about the Zener approach with the P-channel MOSFET. When the Zener clamps the voltage to VGS on, wouldn't that clamp the voltage on the load as well? And my response is, in this application, the Zener diode is acting like a voltage regulator, so I do think that your description is basically correct. And if you think about it, the Zener and the resistor leg in parallel basically regulates the voltage drop going to the load, or it sets that voltage drop to the load. So as long as the voltage drop across the Zener plus resistor leg matches what you expect at the load, there's really no difference. So when the positive polarity terminal is connected correctly, it doesn't matter whether or not you have the reverse polarity protection circuit there. The voltage that you'll see at the load is going to be the expected voltage. When you connect it in reverse, the entire point of that Zener diode plus resistor leg in that circuit is to direct the current away from the opposite polarity terminal on the battery, and that is of course aided by the body diode in that P-channel MOSFET. This last question comes to us from the mechanical drilling versus laser drilling video. Cedric B asks, hi, let's say a well-known manufacturer says his aspect ratio limit is 1:8. You would actually say that as 8:1 because it's the depth to diameter ratio. And he can reliably manufacture that. Do you think that using such an aspect ratio everywhere on the PCB instead of bigger vias would still affect reliability of the delivered boards from the manufacturer? So this is a really good question. Now, normally when manufacturers specify a particular aspect ratio limit, they're basically telling you that they can guarantee reliability of that feature. Now, they're basically telling you that they have the same level of confidence at fabricating that feature as fabricating some other feature. Now, they're only talking about manufacturing yield. They're not going to tell you anything about long-term reliability necessarily because they're really not in a position to guarantee that for all of their customers. The boards they build could get put into different applications, and of course, they have no idea what the reliability issues could be in those different applications. But normally when they specify an aspect ratio limit like 8:1, they could conceivably manufacture to a more aggressive aspect ratio like, say, 9:1, but maybe they can't guarantee the same level of yield and reliability as the 8:1 aspect ratio. And so they're giving you a more conservative number than what they can actually do. So keep that in mind. That should give you a little bit of peace of mind knowing that there's already a built-in margin of safety. Thanks for watching this video and tuning into my channel, everybody. I'm going to keep answering your Altium Academy viewer questions on this channel. And of course, whenever we see a good question, it might make it into its own video on the Altium Academy channel. Make sure to head over to Altium Academy and subscribe. Hit that subscribe button down below, and we'll see you in the next video, everybody. Thanks, everybody.